Hi friends, in this video I'm going to introduce you guys to trigonometry identities. And from our O level, you know that if you are given sin theta, we all know that another identity for sin theta is what? It's just like writing 1 over what? 1 over cosec theta. And if you are given cos theta, you know our cos theta is also written as writing what? 1 over what? Sec theta. And let's say we are given what? Tan theta. We know that another identity for tan theta is also the same thing as writing sin theta over what? Cos theta. Similarly, if you are given cos theta, cot theta, another identity for cot theta is also written as cos theta over sin theta. So these are the basic identities that we have under trigonometry. Then let's move to the derived identities under trigonometry. All these identities, all these basic identities can be used to derive a relationship between trigonometry identities. A relationship between trigonometry basic identities. Now let's say we have let's say we have a half angle. An half angle now. Can I see it now? Let's say this is the angle theta. These are 90 degree, and these are vertical component, and we have our x-axis, y and also x-axis. Then this is going to be our r. Basically, we all know that our y is also written as writing opposite. While our x is the adjacent, and our r is is the hypotenuse. Very simple. So then we all have the basic knowledge of SOHCAHTOA. Let's say we are having SOHCAHTOA. We know our so means that's sin theta equals to opposite over over adjacent, right? And our car means cos theta equals to adjacent over over hypotenuse, right? And we know that our so is actually h, so this should be hypotenuse. This should be hypotenuse. And also our toa. Our toa is the same thing as tan theta equals to that's opposite over over adjacent. Can you see this now? So this is just the basic derivation of SOHCAHTOA. All these are summarized into SOHCAHTOA. But with that being said, in this video, I'm going to prove some identities, some derived identities for you, using my SOHCAHTOA method, and also using Pythagoras theorem. Using Pythagoras theorem, right? Pythagoras theorem is telling me that if I have my opposite, the sum of the opposite square plus the adjacent square, the sum of the opposite and also adjacent square equals to my hypotenuse square. That is, I will be having my hypotenuse squared equals to that's opposite squared, right? Plus adjacent squared. That's it. And we also see as writing r square equals to what's my opposite square? My opposite square is the y square plus adjacent square, which is s square. That is what Pythagoras theorem is telling me. But in this case, without wasting our time, we can just record that our sin theta equals to opposite over hypotenuse. This opposite can be represented as my y, and my hypotenuse is also seen as r. Then I will be having sin theta equals to y over r. Then from there I can make my y the formula. Making y the formula, I'm going to have y equals to r sin theta. Call this equation 1. Then from my cos theta, cos theta also the same as adjacent over hypotenuse. Then my adjacent is taken to be x, and my hypotenuse is taken to be r. I'm sorry for the noise, guys. It's taken to be r. Then let's just go ahead and just insert the variable inside the formula. I'm going to have adjacent is that's my x over r. Then from this, also make your x short of formula. I'm going to have s equals to r cos theta. This is equation 2. Then go ahead and use the relationship of the Pythagoras. Pythagoras said It's telling me that r square equals to y square plus what? Plus x square. Then let's use this relationship to derive our first identity. Therefore, we are going to have, what's my r square? It's also the same thing as what? As r square. Equals to what? My y square. This is this, which is also the same thing as this. That will be what? R sine what? Sine theta. R sine theta or what? Or square, right? Then plus my x square. My x square is also the same as what? As r cos what? Cos theta or what? Or square. Let's go ahead and open the bracket. We are going to have r square equals to what? Equals to r square sine square theta, right? Plus what? Plus r square cos what? Cos square theta. So if you look at this now, the similar terms that we have here is actually the what? R square. Then I can just go ahead and divide all through. Divide all through by what? Divide all through by what? By r square. If you divide all through by r square, you are going to r square divided by what? R square equals what? R square sine what? Sine square theta. All divided by what? R square plus what? R square cos what? Cos square theta divided by what? R square. This cancel this, this cancel this, this cancel this. Therefore, you are having 1 equals to what? Sine square theta plus what? Cos square theta, which is also the same as what? As sine square theta plus what? Cos square theta equals to what? 1. So this is the what? First identities. First relationship identity that we have. Just know sine square theta plus what? Cos square theta equals to what? 1. Then let's move to the what? To the next one. Using this sine square theta plus cos square theta, if I record this was the first my first identity. If I record it, I'm going to have sine what? Sine square theta plus what? Cos what? Cos square theta equals to what? 1, right? But if you look at this, I can just choose from this my basic identities. I'm having tan theta equals to sine theta over what? Over cos theta. I can just choose to what? Divide all through by what? By my cos. In order for me to what? To obtain tan. Divide all through by what? By cos theta. Cos square theta rather, because this one is sine square theta. You are going to have what? Sine square theta over what? Over cos square theta plus what? Cos square theta over what? Over cos square theta equals what? 1 over what? Over cos square theta. Very simple. But if you look at this very well, sine over cos, my sine over cos is actually what? Tan. That means everything here is what? It's also the same as writing tan square theta plus cos square theta divided by cos square theta. That's what? This is 1 equals to 1 over cos. 1 over cos is also the same as what? As 1 over sec. That means my sec theta from this, my sec theta, if you make sec theta as what, we are going to have sec theta equals to what? 1 over what? Cos theta. Can you see this now? So that means I can actually write my sec theta as what? I sec theta as what? 1 over cos theta. Because if you make your sec theta here, let's just try and make it here. Look at this. You're having cos theta equals to what? 1 over what? Sec theta, right? Divide by this, you are going to have cos theta sec what? Sec theta equals to what? 1. Then if you choose to make your sec theta result of formula, or cos theta result of formula, or sec, you are going to have, if you make sec, you are going to have 1 over what? Cos theta. That means my 1 over sec, cos theta is what? That's sec square theta. This is the second what? Identity 2. Can you see this now? Then let's go ahead and derive the third identity. Deriving the third identity, you guys, can you see that I divide all through here by cos square theta? Then the next thing I'm going to do now is just to divide all through by what? Sine square theta. If I divide all through by sine square theta, divide all through by what? By sine square theta. Let's see what I'm going to have. Dividing all through by sine square theta, I'm going to have what? Sine square theta over what? Over sine square theta plus what? Plus cos square theta over sine square theta equals to 1 over what? Sine square theta. Looking at this will give me 1, right? I'm having 1 plus cos over sine. Cos over sine is what? Is my cos, right? This is cos. Then you are going to have cos square theta equals to what? 1 over sine. Looking at this, sine theta equals to 1 over cosec theta. Make your cosec theta straight from now. You're going to have cosec theta equals to 1 over what? Sine theta. That means my 1 over cosec theta, which is sine, is also the same as what? As because sine theta is what? Is inversely is inversely proportional to what? My cosec theta. That means cosec theta is also what? Inversely directly proportional to what? Directly proportional to my sine theta. That means I will be having 1 over sine to be what? To be cosec square theta. Very simple. So this is my basic identity. These are my basic derived identity. That is the derived identity, what we can derive from what using our Pythagoras theorem, and also what my basic identities. Now looking at this, I have what sin square theta plus cos theta equals to what equals to 1, and I have my tan square theta plus 1 equals to what sec square theta. I also have 1 plus cos square theta equals to what sec square theta. Now let's just move to how to apply all these basic identities on the question. Let's try to apply it on the question. Now looking at this, I have two questions here, which are what prove that tan theta plus cos theta equals to sec theta cosec theta. Prove that sin theta plus cos theta all squared equals to plus what sin theta minus cos theta all squared equals to what 2. I'm going to apply the basic identities on these two questions. After that, I'm going to solve various questions differently on a separate video. Now looking at this, I have my tan theta plus cos theta equals to sec theta cosec theta. No, for my basic identity, I can recall that my tan theta is same as writing what sin theta over cos theta, right? And also my cos theta, which is similarly cos theta is also similar as cos theta over sin theta. If I have my cos theta, then substituting this value and also this into the left hand side of the equation, because you can prove from this side and also from this side. Since the question says prove that this is equal to this, that means tan theta plus cos theta, the identity is what sec theta cosec theta. Then let's try and apply these two formulas under this. I'm going to have sin theta over cos theta, right, plus cos theta over sin theta. I want to prove that these two things is also the same as this. Then let's go ahead and prove it. Looking at this, I'm going to find the LCM. My LCM is what cos theta sin theta. Then cos we cancel cos, we are having what sin square theta here, plus what sin we cancel this, that we are having what cos square theta. Then this is also the same as what sin square theta. You can recall that sin square theta plus what cos square theta equals to what 1, right? That means everything here is 1. I'm having 1 over cos theta sin theta. This expression is also same as this, because I can actually separate these two as 1 over cos theta times 1 over sin theta. Then if you recall that, from the basic identity, we know that our cosec theta is also same as writing 1 over sin theta, right? And also we know that our sec theta is also the same thing as writing 1 over cos theta. Looking at this 1 over cos theta is the same thing as sec theta. That means I'm having sec theta times 1 over sin theta is cosec theta, which is cosec theta. This is actually proved. That's how to apply basic identities on any question on that trigonometry identities. Then let's move to question 2. Question 2, you're having sin theta plus cos theta all squared plus sin theta minus cos theta into brackets all squared equals to 2. That means you're asked to prove that everything here is equals to 2. It is very simple. The first thing is that you can actually prove from this side, or you choose to split this into 2. 1 plus 1. You recall that your 1 equals to cos square theta plus sin square theta, then plus cos square theta plus sin square theta. Then you find the way to relate it to this. Now looking at this, I will first open this bracket. That is, I'm going to have sin theta, right, plus cos theta, close the bracket. Then I'm going to have another bracket beside it. That's sin theta plus cos theta. I'm expanding this first before this. Then expanding it, you are going to have you are going to have sin multiplied by sin. That's actually sin square theta, right? This time this is plus sin theta cos cos theta. This time this is plus sin theta cos theta. Then this time this is actually plus cos square theta. Then try to simplify. I'm going to collect this and this together, because I have my identity like that I can use on them. I'm having sin square theta plus cos square theta, right? Plus this 2 sin theta cos cos theta. Can you see this? Then you can recall that your sin square theta plus cos square theta is the same thing as what? 1. Then you're having 1 plus what? 2 sine theta cos what? Cos theta. Then call this equation 1 because this is the first aspect that I expand. Then let's move to the second one. Expanding this, right? Which is this. I'm going to expand it right now. I have what? I have sine theta minus what? Cos theta. Close the brackets, open another bracket. You're having sine theta minus what? Cos theta. Then I want to expand it. Expanding this, you're having what? You're going to have sine square theta, right? This time this that's what? Minus what? Sine theta cos what? Cos theta. Again, multiply this by this, you are going to have minus what? Sine theta cos what? Cos theta. Then this multiplied by this will actually give us what? Plus cos square theta. Then I'll try and collect what? And simplify, which is collecting like times together. The one that you can apply identity on. If you collect one that you can apply identity on, you're going to have what? Sine square theta, right? Plus what? Cos square theta minus 2 sine theta cos what? Cos theta. You can actually recall for this. Recall again that what? Sine square theta plus what? Cos square theta equals what? 1. That means everything here is 1. You are having what? 1 minus what? 2 sine theta cos what? Cos theta. Very simple. Then let's go to the final step. The final step is that you guys know that I actually expand this and also expand this, but there is an arithmetic operation sign here, which is addition. That means I'm going to add my equation 1 and also what? Equation 2 together, right? Adding this and this together, that's what I'm going to do right now. Then I'm going to have 1 plus what? 2 sine theta cos what? Cos theta plus 1 minus 2 sine theta cos theta. Can you see this now? So in this case, look at this very well. This will cancel this, right? Then you're having 1 plus 1. 1 plus 1 is what? 2. Can you see that it is what? Proved. Proved. Alright guys. Let's actually revise what we have learned so far. These are the basic identities and the three major identities. The three major identity that you guys are supposed to know is what? Is sine square theta plus cos theta, which is what? Equals to 1, and tan square theta plus 1 equals to what? Sec theta. Then you are going to know that you are going to have it in mind that 1 plus cos square theta equals to cosec square theta. So in this case, I'm going to solve some questions that relate these two identities together in a separate video actually. But if you check my playlist, I have a lot of trigonometric questions that I've solved using different identities. So if you actually find this video useful, you can just give it a thumb up and kindly like and subscribe to this video. Do well to share the video and don't forget to click on the notification button. Thanks for watching.